Hello, everybody, and welcome to this Sparring Partners with Cristina Rodriguez at Intel. As always, it's a pleasure to be here, and it's a special pleasure to be here with Cristina, a friend of mine, and so it's great to have this chat because it gives me the opportunity to catch up with her as well. So the topic today, AI everywhere from the edge to the cloud. And this is part, if you've noticed, I know a lot of you are uh, frequent attendees in these events. You notice that there is a lot of sparring partners recently on AI and automation. This is not by chance. It's because of my interest, but also because I'm writing a report on this. And so we had previous sparring partners, which are also going to be part of the report. This is one of them, and there will be more coming up, and we'll get at the end, and I will send you links to them. So this is sort of part of a program. We're digging deeper and deeper, and today is going to be a great thing that we can do because Cristina is doing a lot of work on this. So we will skip the sort of generalities and we will go into the details of what people are doing and not just what they're talking about. So no slides, as always, just a conversation, but it's a conversation about things that are happening, not about things that you see on a slide. Said that, I'm going to have the few housekeeping items. If you've already been on a Sparring Partners before, this is a conversation. So we talk back and forth and we listen to what you say. So there is no Q&A at the end. And we encourage you to participate, to ask your questions as we go along, and we'll do our best to take your questions as they fit into our discussion flow. So the sooner you ask your questions, the more likely you have to have it answered, and then you can follow up on that. And we definitely want to hear from you. So feel free to ask your questions. Other people can see them as well. So be polite and respectful, and you can comment, you can talk to yourself among you as well. But again, be respectful. But say what you think. We appreciate it, even if you disagree with us. Okay, so said that we can get started. Again, questions as we go along. It's a conversation, informal. And so we're going to talk today about, as I see what I titled, AI everywhere from the edge to the cloud. So clearly AI, it's a useful tool. And it's a useful tool. You want to think about it as something that it applies across the network, but in different ways. And so what we're going to talk about with Cristina today is what's going on today. And we'll also look at the sort of long-term part, but what happens today in different parts of the network. With that said, I'm sure most of you know Cristina, but I will nevertheless ask her to introduce herself. And then, so you get a context of what she does at Intel and with the partners, and then we'll go with the conversation. So Cristina, thank you so much for agreeing to be with us today. And you know what, we talked many times, I've seen you many times, but I don't think you've been on a Sparring Partners before. So welcome to the show. So tell us.
Monica, first of all, thank you so much for having me. Always super fun hanging out with you on any occasion. And you're right, this is my first time here. Super excited to have this hour to talk to you and have a conversation about AI. Looking forward to it. It's going to be fun. And introduction, again, for everyone, I'm Cristina Rodriguez. I am Vice President and General Manager of the Wireless Access Network Division at Intel. Basically, I own the RAN business, bringing together 5G, the build out of the edge, artificial intelligence in an open virtualized RAN.
Excellent. You own the own business. That's pretty. that's a lot of work right there. And I know that you work with a lot of partners, so that's all very exciting. So to get started, I know you want to talk about what's important today, what's going on today. And this is interesting because oftentimes when we think about AI, so there are two things. There are two ways about it. Some people think about AI as like sort of a thing in the past because now we have Gen AI, so it's kind of like legacy, which I think is wrong. But anyway, and then there are others that think, yeah, AI, great, but it's all going to be in the future. And you take a different road, like it's in the present. So can you tell us a little bit about what's your view, what's your take on that?
Yeah, no, that's a great way to look at it and start the conversation, Monica. Definitely very much in the present. We for sure believe that AI is gonna be everywhere in the future, for sure, from cloud to core, edge, RAN, everywhere in the network, everywhere in our lives. And but we have it right now already. And what is more important is that we have made a lot of progress into it. There is a lot of things that we have right now, a lot of technology, mature technology that we have right now that we can start using it, applying it, and then evolve it as the technology continue evolving and the requirements of the society and the different industries continue evolving.
Absolutely. And I think that it's also not, to some extent, it's not a black and white type of situation, in the sense that you start using AI and ML gradually. So it's not going to be that overnight everything is AI, because you don't want to do that, right?
Absolutely, absolutely. And this is a complex technology too, and you are replacing the AI is replacing the way things are done today. So nobody, and you look, for example, in networking or in radio access network, which is my area, there are algorithms that are being there forever. There are operational practices that have been there forever. And they were looking at it and say, hey, we're going to replace this with artificial intelligence. And it's not going to happen overnight. You have to test that. You have to get the data. You have to create the models and train the models. And then you have to apply those models and execute those models and trust them. And it's going to take testing. It's going to take fine tuning. It's going to take trusting that way to do things before the switch happens. So yeah, I agree. It's not gonna be one day overnight. Everything is AI driven.
Yeah, actually, next week we're going to have another Sparring Partners on the human component, because that's also, as you say, you need to build the models, you need to trust them. And that requires us, meaning humans, to engage in it and to do things differently. It's different from, say, having a a 5G network. So you have 4G and then you launch 5G, and then, yeah, there are different parts to it, but you either have it or you don't. With AI, it's just, I guess that the challenge is that you need to start doing things differently. And that's a culture, it's a technological change, but it's a cultural change as well.
Totally.
Okay, why don't we get started with the use cases? And as I said, we want to talk about real stuff. Okay, so what let's just get started. What do you see as the sort of the main use case? If you, again, as you say, AI is going to be everywhere, but if you have to pick one use case that it's really going strong right now, what would that be?
So that's a very good question. So the way I look at, and this is, of course, I'm going to put AI in the context of what I focus on, the radio access network. The way I look at it, there is I'm going to say two levels of AI, how AI gets applied to the RAN. One will be in the infrastructure of the network. And there are things that we can use it today right away and that we have seen we have proof of concept with operators, and we have demos with operators and seeing the benefit of it. And I'll give you some examples later. But for example, in that network infrastructure will be power management, how to have more efficient networks, or things like predictive maintenance, right? The learning of the network to understand when there is need for a maintenance. That will be happening in the infrastructure side. Two examples. Now, in the radio itself, in the radio algorithm, then again you can have AI applied to link adaptation or channel estimation, just different beam weight forming. So things that are specifically to the radio, to the layer 1 and layer 2 and above. So both things are happening. We have examples with operators, and it's very much something that we can start applying, and that the operators are starting to apply right now.
Yes, and I think that this is important to keep in mind. It's not just one. I mean, again, it just requires everything to, a different approach to the old problems. It's the issues are the same, like power efficiency, spectrum efficiency, those are the same. They haven't changed really, but we have a different way to attack them and tame them. So that's very interesting. Any specific examples you want to talk about?
Yeah, that's so we have, for example, and this is something we demonstrated at NWC this year, NWC 2024 in Barcelona. We have a few works that we have done with operators, and I mentioned just a few of them. For example, we did a work with Vodafone, where we demonstrated AI-assisted network slicing radio resources management. And I think network slicing, we're going to be talking a lot about network slicing, I believe, in the next in the next year or so, because I think it's gonna be important for the industry. And in this demonstration, not only we were able to meet the SLA, the service level agreement, but we were able to improve radio resource efficiency by 2.5 times relative to manual slice management. So really impressive. That was with Vodafone. With Deutsche Telekom, the tag, we also demonstrated AI-assisted beam management, and we were able to show 2.47x throughput gain, pretty impressive, and 3.5x delay reduction at the cell edge. Really, again, really significant. And then the last example, or actually I'll say one more, we also work with AT&T, and this is in the energy saving, which we have made a lot of really progress, and we have done this before, and this is another demonstration. But basically, with AT&T, we demonstrated 16% of energy savings, again with AI assistant, frequency scaling in a virtual DU, and that was over and above a policy-based approach that already implements frequency settings based on a typical history traffic pattern, so above and beyond. Really good stuff. And then the last example that I'm gonna mention is the work that we have been doing with Ericsson, also in the energy savings. We have our joint tech hub, and again, focus on AI collaboration. And this is actually more than a year old, but we demonstrated up to 20% of energy savings with dynamic power management using the Intel Xeon C states that are integrated, that are part of the Xeon SP capability, our platform. And that's, again, this is part of the beauty of AI, is the new technology, but it's taking also the best of the capabilities that we have in our CPU and taking it to the next level.
Absolutely, and I just sent a link to the interview we had last year on power efficiency, and it's amazing. increase in efficiency, cost savings, sustainability, and all that. That's just an example of one area. But one thing that with AI you can do, I guess, is to not only get those efficiency, increase in efficiency, but also to test it before you implement it. So like you can have a digital twin, or you can have a simulation where you see, well, if I do this, what kind of efficiency am I getting? So that you can do that before you roll out. So
absolutely,
oftentimes we think about AI as like, just put you in a sort of more dangerous situation because you can't control it. But I would say that it's the opposite, because you have a way to see what would be the results if that's, and it's called digital twin. I used to do philosophy, and that was a possible world in the old days. That's the way it was called. But if you just think about it, it's the same way. It's like, what would happen if I did that? And so you can see, because there could be something good and something bad. Is that the way?
Yeah, and that's a very important piece or phase of this journey, right? You have, again, you create the models and you train the models, and then you test them in the lab, and then you fine tune, and then you test it with a little bit more of exposure in a commercial environment, then you fine tune. So it's a process where you test, you fine tune, and it gets better and better, and you can collect more data, and that is feeding into your results. So it's part of the process.
Now we have the first question from the audience.
All right.
From Aziz, and actually a very good one. Where do you think that the use of the AI might hurt rather than help the RAN? Which I guess it's an issue, because if you try too hard, you might end up not improving things.
No, but I think that's not, you don't let it to get there, right? And that's again, that's what I was talking, and we have had this conversation with many operators, and the network today works really well. That's a reality, and that's one of the reasons why things take a little bit longer to change, because it's working really well, and because you want to be able to make your phone call when you need to make your phone call, and access your data when you need to access your data, and nobody's going to jeopardize that, right? The operators are really stringent, they really demanding requirements for themselves, right? Like as far as KPI, performance, and quality of quality of the connection, and quality of service, and nobody's going to jeopardize that. Well, the way this work is, you, depending what area, and again, I go back to the different areas in the infrastructure, or in the layer, in the actual stack, the radio stack. You go and you test and you capture data and capture more data and test, and then when you feel that you have what you need to have, then you deploy that. I talk a little bit about I went very much into the details of a couple of examples in the use cases, but let me step back a little bit and give you a little bit more high-level view of the use cases, right? So for example, dynamic network configuration. This means that you are going to be able to manage hardware resources and through software-driven resource allocation, right? And by doing that, you can right-size the network in real time. You have a very granular, fine-grained control of your resources. So that's one aspect. Another one is, we talk about it, and this is probably one of my favorite, and the one that can be that we can start using right away. Energy management, right? You have all the telemetry, real-time telemetry data that provides visibility into power consumptions. You can control core frequency, voltage, dormancy levels in an automatically way, and adjust it automatically, give you fantastic results. Traffic sharing, or traffic steering, actually. Traffic steering. You can balance traffic among multiple cells, and you can correct coverage and capacity problems on the fly. And by doing that, you improve the customer experience. spectrum efficiency. Operators have done an investment on spectrum, as we all know, and one of the most important things for an operator is to get that return of investment, and the efficiency of the spectrum is super important. So you're able to automatically optimize that that spectrum, and as by doing that, you get better network throughput, better reliability. So that's another case. I talk about predictive analytics and controls. How can you react to changing network conditions? Not only react to network change conditions, but also predict those changing conditions, and then take actions depending on the study, the KPIs, and take actions on that. Network security, another example, detecting and responding to anomalies more efficiently. And then finally, the other one that I'm going to say is the network slice, which I think is going to be super important for the future. And we'll probably talk again about that later in this conversation. I'm sure it will come up, but it's an opportunity for the operators to get new revenue streams and for the user to get new services that are going to improve the quality of service. So again, network. By applying AI to a network, what you expect is just you improve efficiency, you improve reliability, and you improve security.
Absolutely. So back to the question is that you're not going to make things worse because you're going to make sure that that doesn't happen. Yeah. I mean, clearly, anything you do, you can, but so there are ways in which you can control it, see how it, it's working. Now, one thing that, across all the cases you said, you mentioned the use cases, one thing, well, a few things come forward is the fact that basically what AI is doing is allowing operators to use data they already have there to improve the efficiency. So it's a better use of the existing data. Now, is that easy to do? I mean, clearly it has not been easy in the past because there was so much data. So is AI helping you to manage that data better and also to do it more quickly? Because if you say, oh yeah, that's what you should have done yesterday, that doesn't really improve efficiency today.
Yeah. I mean, think about it, right? A lot of the operations that is happening in the network is based on the experience that the operation engineers have. And you're making decisions on network configuration, or provisioning, or taking actions, or deciding when to do a maintenance, or moving resources. A lot of that is happening based on the experience of the operation of the network. Instead of now relying on that, which is very important, but instead of that, what we have all this, so we can have access to this massive amount of data from years and years and years of network operation that can be collected, analyzed, and then used to make better decisions. You just have a combined massive amount of experience that now you can utilize to make, again, better decisions.
Absolutely. And yeah, and there is a massive, so we have in the network a lot of, in the organizations, there is a lot of humans with a lot of experience, but the data itself gives us a lot of, sort of say, experience in the sense of trying to figure out what is going on. And the other thing that you mentioned is that it not only tells you what to do now, and we can talk about real time later, but also to predict the future. How does that work? Where do you see, what kind of use cases do you see? Clearly there is a predictive analytics, and can you give us some example of how that?
Yeah, in general, right? Things like anything that reflects on a patterns, behavior of the network based on conditions, right? If you have the data that is telling you, hey, under these conditions, we saw that this happened. And that could be a good thing, or it could be a thing that you want to reinforce, a thing that you want to avoid. So based on that data, predictive maintenance is one example. You see these conditions and you know that you're going to need a maintenance. Let's do it, right? Or you see this congestion in the network. Hey, let's move the resources in a different way, or let's balance the traffic among cells in a different way. So it's learning from what happened, the behavior of the past, and applying what would be the best course of actions based on that data.
Yes, and I guess that I mean the issue here is that the data is already there. So without AI, it's really hard to sift through the data and make sense of it.
Yeah, it goes back, right? It goes back to the experience of the operators and the things that you routinely do, like and I go back to predictive maintenance because it's so easy, such an easy example. Maybe you schedule your maintenance certain, and you know that should be okay if you do it certain time, but you could optimize that. Maybe you needed to do it sooner, or maybe you don't need to do it sooner, and you can afford a little bit longer times. Just give you more options.
And I guess that what you were talking about before and I'm glad you pointed out that actually our networks work very well, because clearly there is always room for improvement, but there is a sort of we start from a high a level where we have good performance. We don't want to threaten that has to stay there, but also what that causes is this, a little bit of risk aversion, because why fix something that works? And the reason I would say that a lot of networks work so well is that they're basically over provisioned, because that's a relatively, well, in the past was the affordable way to make sure that everything works. Just throw resources at it. And now with the tighter financial constraints, you can do that. You cannot we can't afford to over provision the network anymore. And then if you try to avoid that, clearly you need to be more efficient.
Right.
I mean, that's the way I kind of see it. So is that I would say that a lot of the cost savings and the efficiency come from avoiding the over provisioning that we had in the past. Do you agree with that? You think?
Yeah, I think that is provision, right sizing. I used this phrase before. Right sizing for the moment, for the condition, for what you have at any moment. And that's why every time we talk about AI, we talk about improving efficiency, because you want to have the resources that you need, not less, not more, and ready to go. And then of course the reliability, because you don't want that. You still have to be reliable. It has to be, you can't come, you can't bring the network down at any point. And, you have to be secure. And the other thing that I would say also that is important is the operators without doubt are looking for total cost of ownership. You mentioned indirectly that total cost of ownership is important for the operators. The operators have made tremendous amount of investment in the 5G network, both in spectrum and infrastructure. The operators are now like, okay, I want to get this. I want to get my return of investment. Is the fair question? So how can they lower the total cost of ownership, and then by doing that, getting back some of that investment, and I think applying AI to areas where we'll make it more efficient is a way to use total cost of ownership. And then there is also opportunities for new source of revenues or new source of ROI, SLA. I'm sorry, slicing is one of my favorite network slicing, one of my favorite topics, because if the operators can have different SLAs for different type of expectation, and they can back up that SLA, that service level agreement with AI, then you have that confidence to go and offer the service and give a new quality of experience to the user, but then at the same time the operators can recover the investment that they have, or part of the investment that they have done. It's a win-win for everyone.
So, so what, if you think about, like network slicing, how is it that AI is doing something that they couldn't do otherwise?
So it's if you in your, let's say that there is a slice that is guaranteed you, and I'm gonna put a very simplistic example, that I guarantee you certain data rate, certain bandwidth, certain throughput, and now you can use AI to make sure that you move the resources in the network automatically, so at every point that guarantee is there. Like, because if not, you have to guarantee, and then you have to over provision because you are guaranteed, you are charging for that guarantee, right? But if you have AI making that trade-off very efficiently in the background, then it costs you less. Then you can afford to do that because you don't have, going back to your statement, you don't have to over provision, you don't have to put guardrails that are unnecessary because you don't want to miss that SLA.
Absolutely. Now we have another question from Aziz, and other people in the audience ask your questions too. So this is a question for you, Cristina. How do you ensure that the use of multi-AI does not cross each other tasks and become the game of cat and dog? So I guess, and I guess this is an issue, I guess in general, right? Because you have the network is increasingly complex, and that's one reason why you need AI. But on the other hand, the complexity leads itself to potential conflicts, which are not even, well, they're not caused by AI, but that AI has to deal with. So how do we deal with that?
Yeah, I think again, this is a complex technology, right? And I think we are just scratching the surface right now, and it will become more and more part of our life, and it will become more natural and less mysterious, I would say, as we move, as we move forward. It's going back to testing. How do we make sure that when you're applying two different algorithms, or two different, you're applying AI to two different areas or two different algorithms, that you are not in conflict with each other. I don't think it has to be in conflict. I don't think it has to become that it doesn't have to be in conflict with each other. If you look at for example, what we're doing and the proof of concept that we're doing, you look at the energy efficiency. You are deciding what to do, for example, with the C states in the Intel Xeon. When are you putting the cores to dorm, and when are you bringing them down? That's pretty contained there. So there are cases where are going to be very contained, and there are cases where they could be a little bit more overlap, and then it's about, again, testing and getting that, running the models, and testing and getting that confidence that everything is gonna, and everything is gonna play as it should be. But it's not. But I don't want to simplify. This is complex, right? This is complex, and again, that's what it's gonna take. It's gonna take time to be able to roll this in full capacity.
Absolutely. And that actually also changes the way we think about the testing and what are the moving parts involved. And that's going to be much, how do I say, much more involved process, because you want to definitely test, and we have the tools to test better. That's the other thing, is that
right,
with increased complexity, but you also have better tools which deal with it. So it's kind of like all comes
that is very true.
Comes together. And now one thing that sort of comes to mind now is the Open RAN situation, because you mentioned slicing, energy efficiency and all that, but when you get to all of that in a context, in an Open RAN context, where not only you have all those things you want to do, get the TCO for 5G and more efficient, but you also have an ecosystem that is disaggregated, where you have multiple vendors. And so how do you deal, because that's a sort of another another direction in which complexity increases. So
yeah.
What is the role of AI there? Is it going to help you, or is it going to slow you down?
Yeah, I think, let me step back a little bit. I think I would say that Open RAN and virtual RAN and AI are meant for each other, and both benefit from each other. I think when we were starting talking, and what are we? Are we starting to apply AI, and are we ready for this? We are, and the reason we are is because we have the maturity and the technology today. I think it's important, and one of the things that is helping AI coming into to assist and to be a critical technology in the RAN, in the radio access network, is precisely the fact that as an industry we have embraced a software-defined network, end-to-end, from core to RAN to edge, an end-to-end software-defined network that can be driven by software and by the work of many developers in the ecosystem. And then, in addition to that, back to the maturity of the technology, is what is underneath that software-defined network that we are embracing as an industry. Look at our Xeon CPUs that are part of that, or that are underpinning that architecture, that software-defined architecture, with the capabilities that they have, not only the AI built in, but also the fact that whatever you do in software, you're going to be able to port it, you're going to be able to upgrade it, you're going to be able to move faster and to refine faster what you have in there. So I think the fact that we have that kind of architecture, software architecture, give you a lot of a boost into AI, because now you can have a model, or you can be executing a model, and you can change that at a speed of software. Basically, the level of innovation that you can bring. Now, innovation is at the speed of software, which is always faster than at the speed of hardware. So I think it's fantastic where we are in the industry and the technology. We came to this conclusion that we had to embrace a virtual open RAN with multiple, going back now to the open part. Now we have a rich ecosystem, a lot of different people participating, different partners in the ecosystem world participating and bringing innovation into the network, into AI, and that's just gonna accelerate things much more than if we wouldn't be in this type of architecture.
So you see that AI is going to accelerate, because it's going to basically, it's enabling the participation, or the participation, or the existence of this wider ecosystem where everybody is working. And I guess it's the software type of how can I say, you're not waiting for 5G, 6G. So in a software based, in a virtualized network, things change more rapidly, and you need to make sure so you need to be able to test them, to monitor them, to optimize it in sort of a real time. And so that's where I guess you really need to have a good model to do that. Is that?
And I think I would say it's feed each other, right? Mm-hmm. So AI enable the ecosystem enable AI, and it just feeds each other and just gets better and better, the combination, because it gives opportunities to the ecosystem to think, hey, I can apply AI into this area, and I can bring value to the operators in this area. And then at the same time, because it's because there is a big participation and there's open interfaces, then it's easier to roll out those new applications, or new techniques, or new ideas. So it just fits each other.
Yes, and so now this is really interesting. I mean, like, again, it's a lot of work. There's a huge opportunity, but it's also a lot of work. And so when you go and talk or work with the operator, proof of concept, you show them, this is all the great savings and improving efficiency, all of that. What is their reaction? Are they, say, yes, let's do it and put it in a commercial network, or do we need more time? Do they have the people to do it, to actually implement the changes? What's the reaction?
Yeah, I think everybody's excited with right off the bat, and I'm maybe taking us back to maybe a year of more of ago conversation, everybody excited, everybody's like, okay, show me, right? Okay, this is fantastic in paper, you are great, great ideas. And I'm talking now a year or more ago. Now let's show me what you can do. And then that's how you go. It's a process, right? Then you show it on a proof of concept, and then you show on the lab, and then you bring and you continue stepping into it until you get to commercial. But I think everybody in general in the industry realize that this is an opportunity, that this is real, that it can have an impact on it. And the other thing that is part of the conversation, one of the things that is important in AI, you have to take AI in the context, in our world, in the context of RAN. So it's, again, in the ready access network, right? We're talking about, cell tower with a base station there. You have very demanding performance per watt requirements, and you have to be very careful how you use your resources. So adding components to your base station, to your virtual DU, is not a good idea unless you need it, right? So one of the things that we are bringing from Intel point of view is, hey, we have a Xeon, and we announced we already have our fourth generation of Intel Xeon scalable processor. We codenamed Sapphire Rapid E, and that's already having a tremendous success this year. And in MWC, we announcing the future generation codenamed Granite Rapid D. But again, what we're giving to the industry is the possibility to run their AI, not only the RAN workload, the entire RAN workload, all the way from layer 1 in a virtualized way. Not only you can do that, but you can also run your AI workload with a combination of the built-in AI acceleration that is already in our CPUs, and the combination of the instruction set that we bring, and the architecture that we bring, and the software, the reference software that we have. You put all that together, and what that gives you, that you don't need any other component to run AI. And that's critical, because if you had to add a component, now you have to think about, what does that do to my power consumption? And with our solution, you can run the entire workload again without having any additional component. And that's all. Every single proof of concept that we have done have not required any additional GPU, any additional PCI card. It's all running on Intel Xeon, in our Intel Xeon scalable processor.
Now, let's get back to the operators later, but let's talk a little bit about the sort of the chipset situation. And clearly, and I think that, in general, you don't want to have more complexity and more moving parts than
exactly.
You do. It's the Occam razor, right? You just like,
yeah.
So we should learn to manage complexity, but not get over complex. So
exactly.
You don't want to have so many vendors that you go absolutely crazy, because every vendor adds some level of complexity. So you want to keep complexity only if it helps you.
Exactly. Absolutely. Yes, absolutely. And complexity from the securing from the component point of view, on the supply chain of view, but then also now you have a different model, different software tools, different approach to do the whatever functionality you have to do. And what we're saying is, hey, you have our Xeon, our Xeon server architecture, the one that you have done, the one that hyperscalers have used for so many years, and have a scale up so successfully. You have that. You don't need anything else. You run your software, you write your software the way the whole world writes software, nothing special. You write your software, you run it. And not only that, generation over generation, every time you go from one generation to the next one, every single investment that you did to your software, you can run it again. And this is one of the things one of them that we're super proud of. We have comments from our customers that say, have gone from one generation to the next one, and they say, and it has been an out-of-the-box experience, meaning I recompile one button, and everything that I did before works in the next one. And that's super powerful, because you don't want to have to start all over every year and a half or every 2 years. You want to be able to take right away, take advantage of everything that you invested and everything that you did already in the previous generation.
Absolutely. And yeah, and I guess that there is an issue of like continuity, basically legacy, dealing with the legacy, what eventually becomes legacy, right? And then look at it. But let me ask you a little bit of a devil's advocate question here. Could you say that it's really good to have everything, all the AI components built in, so you don't have anything separate? But on the other hand, does that one potentially create a limitation? Because if I want to run some other AI optimization, which is over and above or different, could it be a conflict? Or is there a situation where you're kind of stuck with a solution that might not meet your needs?
It goes back of what do you need, right? What are you gonna do in the video? You're not gonna train a model in the video. You do that somewhere else. And that's a different activity, right? But what you need to do in the video that is so latency sensitive, so performance per watt sensitive, you need to run your models, you need to execute your models in a way that doesn't affect latency and efficiency and performance per watt. Then the AI acceleration that we have in there is dimensioned for what it needs to do. Right? This is one of the things that we are doing, and I think we're doing very well, is understanding. We've been in this space for a long time, I'm gonna say, and we understand very well the requirements of the space of the brand. We understand the use cases. We work very closely with operators, with teams, with many partners. And we're starting this journey knowing the brand and then knowing AI and applying AI to the brand. So you dimension for it. Going back to, you don't want to have something that, yes, is so powerful that you could train, but I don't want to do that. And I don't want to pay for the power consumption that will bring. I just want to have what I need. That's the key of it. You want to have what you need at the time you need it, in a way you need it.
Yeah, and I guess that this is actually an important issue that you raised, is the power consumption and the kind of, where do you need to have your own model, basically? Because to have your own model, to train it, to develop it. So first of all, it takes a lot of money and effort to build it. And then you're trying to do whatever else is doing. I mean, in a sense that there are some common problems. So you don't want to reinvent the wheels. And there have been some announcement from operators saying they want to build their own models. And I'm like, well, at what point do you need to do it again on your own? I mean, why not use what's already available by somebody that really does it? Like, obviously, chipsets better than an operator, because that's
right.
Sort of like goes without saying. So, and I guess that the issue of power consumption, because we try to be energy efficient, but these models might use a lot of power to develop, train, and maintain, and so you can basically streamline that, right? So I think that this is an important consideration that is often lost, and you can introduce power consumption by not generating additional models itself.
Exactly. Yes.
Okay, very good. So, actually, sorry, I forgot. There is another question from the audience here. I'm not sure I really understand it. So this is again from Aziz. So I'm going to read it, and then you see whether you can make sense of it. So will it be better to deploy AI on the RAN to reduce the delay rather than use it on edge and pay for the extra interface and shaking? So I'm not sure I understand it, but I think that it kind of points to the fact of, which is kind of related to what we're talking about, which is, okay, AI is going to help you, but where? Is it more in the cloud, at the edge? Where do you?
Yeah, and I think
where is it? Where does it live?
Yeah, I think I'm gonna say I'm just gonna say it's everywhere, and
Mm-hmm.
you have to have it everywhere, because here's the thing: when you in the RAN, you'll have in the RAN and you have in edge, and Aziz bring a point about latency. Latency is super important, and that's why the RAN specific AI, you gotta run it on the VDU, right? You can't go to the data center, you can't go to the centralized unit. You gotta run in the VDU because you need real-time data that you cannot afford send all the way to the centralized unit or to the data center and back. You have to run it right there and make the decision right there. And those are RAN algorithms, radio algorithms, and specific to the VDU actions that have to be taken. But again, we're talking about layer 1, layer 2 infrastructure in the network. Now, at the edge, then you're going to be running applications that, again, similarly, you want to, this is the reason why we build out the edge, because you can afford, for latency reason, send the data all the way to the data center and back. So you're going to want to make decisions right there and dimension your edge equipment for what you need to do. Things, for example, and I'm just going to make an example, video-related applications. You want to have your video-related applications that are latency sensitive taken care of right there at the edge, right? So again, what do you need to do? What are your characteristics? What are your KPIs as far as latency, performance, reliability? Where do you should have your capabilities built in the network? And I don't think it's one or the other. I definitely think it's, again, everywhere.
Again, another devil's advocate question here. Is that going to create an additional cost at the edge? Because clearly you need it there, but you need AI. AI is more intensive. And I guess that one way to look at it is like you might have AI at the edge, but you don't need to have the whole model. So you can have a general model that you train somewhere in the cloud, but then you kind of, once you have it trained, you have a specific instance in the RAN. So that, because you don't want to be in a situation where at the edge you need all this infrastructure to manage the RAN right there, which obviously you want to do for latency reasons.
Yeah, same thing, right? What do you do? What kind? You're gonna be doing your training in the data centers, yeah, in the centralized in the centralized unit, or in the data center mostly. But you want to have what you need to execute the models at the edge and at the RAN.
Okay, so
you have to provision the same thing, right? You have to dimension and provision for based on your KPIs for what you don't want to throw resources that you don't need, because that translates in cost, power consumption, complexity. You don't want to do that. You want to have, and again, this is and I go back to this unintentionally, really, but this is why having the Xeon, the Intel Xeon CPUs is so beneficial, because you have that AI built in that allows you to do AI at the edge without having to raise your cost. And maybe you need additional functionality in certain specific cases, but again, it's all in the context of what do you need, right? You might need additional assistance for different applications, but you have to look at the entire application. What are the KPIs and what are the goals of that application?
Now, this is really, you raise very, very important points. Is that you can do different things, but you really need to understand what are your needs and what is the best way to go about it. So that's kind of before you even you think about AI, you need to have a clear view of what is that you're trying to do, and then you say, okay, this is where AI is going to be more helpful. So what is, after all the experience, you've been working on so many, projects on this, what do you think is in terms of real commercial deployments, what are the best practices? How is that operators should go about it? Because clearly they're not going to jump right in there you want to be careful, but at the same time not take forever.
Yeah, no, that's a really good question, and I'm glad you asked it, because we are as Intel, we're in a very unique position, and we're very grateful to be in that position, that we have been deploying virtualized Open RAN for a few years now. And today, pretty much every deployment or nearly every deployment of a virtualized run is happening on Intel Xeon processor. So we're getting, number one, that first-hand experience of deployment in a software-defined network, but also we're having a very close relationship with operators and TEMs and just the RAN industry and the networking industry in general. And the approach is exactly like that. You have to start, it's good to start, and this is going a little bit back to one of the questions. When you have a well-contained AI application, that's even better, right? Like I was talking about the energy to start with. You have the energy efficiency application applying AI, and that's pretty well contained. So take that, put it in the lab. We'll do a proof of concept, put it in your lab, and then take it to the next level. Use all the data that you have available, and then put it on, create the model, fine tune the models, put it on the lab to execute, and then take it, from there. More testing until you get to a point that you feel good that you can have a commercial trial or field trial, and then you take it from there. So it's definitely a step approach, and that will go from every single application. You had to try it, you had to get comfortable with it, both from the data that you get from the testing, but also mindset, right? Because it's a big step when you say, yeah, I'm gonna let this code live on its own, right? And I'm going to step back. So you have to build that confidence and then deploy. But we're going to get there. It's a part of the evolution. There's no question in my mind that we're going to get to a point that we're all going to be like, yeah, of course, that was the big deal, because it's the way, because we're going to be mindset and technology so far ahead.
No, absolutely. I'm completely with you. And I think that, it's just a question of how we get there. And I think that, within this, the sort of the trust part is going to be crucial, because it's something that is so completely different. And trust is something that is difficult to define more so than, what is Open RAN or what is 5G, whatever. Trust is kind of like, what is it? How do I know, this is like, how do you know that you can trust something? So how do you recommend that operators sort of get to a situation where they trust those models and the recommendations? And actually, that's for you too, because when you have you build your own model, your people have to trust the model too. Yeah, so it's not just an operator, like, that is just for everybody.
It's like everything, right? I recommend you start one at a time, one step at a time, put it in the lab, have it compare, because you're going to have to compare. How is this better than what I had before? And you have to be able to compare apples to apples, and you put it in the lab, and then you take it for all the way through your validation cycles, and until you have those KPIs that makes you feel good at the lab, and then you take it to commercial and field trials, and then you take it to full commercial. Is in some ways not different than what you do with any new generation, but you build in that confidence, and when you see that everything is working, and the first time you deploy and you see it works, you're like, okay, this works. Let's go back and do some more. This is really cool, right? So it's just a build. It's like everything with trust. Trust doesn't happen overnight. Trust is something that you continue building on.
Yeah, I guess it's sort of an interactive
process. An interactive process.
Yeah.
Yes.
Okay, we have a final question, and then we're going to have to wrap up. It's as mentioned in many places where AI models can play a role on the internet, such as optimizing performance on the edge in reality. So where will the data from training and turning those specialized AI models come from? Are operators or major players willing to share such kind of data? And my understanding is like a lot of the time it's going to be your own. I mean, each operator will train the model on their own data, so they don't need to specifically share it, right?
Yeah, the data is with the operators. That's what it is. But then it is think about it, right? These operators have been doing this for years and years and years of data that you can collect for each of the operator. There is enough data there to create very powerful, very solid models. So yes, it's with the operators.
Absolutely. Now, very final question. So we talked more about the sort of short term. What is that you're doing can be done today? But clearly, it's a big, it's a long term project here. It is a long term change. So what do you see happening now versus the long term?
Yeah. So again, now we are getting our feet on the water, right? Let's have, what can we put here? And there's already operators, by the way, there's AI already in the current system in different degrees. But it's like, how can we get this started? Start to deploying, and I think we'll start seeing deployments of this in a more generic, in a more massive way. I'm going to say I start seeing this in certain areas, and again, building up, putting out there. I think energy efficiency is a no-brainer. Some of the radio algorithms are also, I'm going to say, no-brainers. It's complex, but it's no-brainer to roll it out because it's it's easier to contain. So you will see that rolling out. Future is everything, every single thing. The AI is going to be everywhere again. And of course, there is one of my favorite topic, and I think it's your favorite topic, or one of your favorite topic, Monica, which will require another hour. This is not a good way to end the conversation because it's the zero touch automation of the network. That's the dream. That's an operator's dream. When you have a network that can self-learn, can self-heal, is completely self-sufficient. You don't have to touch it. No manual intervention, and it's running efficient and reliable without no, again, human intervention. So that's obviously the dream. I think it is going to happen in certain, again, in a not overnight, but in stages. And that's I'm looking forward to that.
Well, Cristina, thank you so much. We're at the top of the hour, so we need to go. But I'm with you. Yes, zero touch is really the ultimate goal, and I don't think it's impossible. No, not really it's impossible. But as you said before, at some point we're like, oh, obviously it has to be that way. We just need to get there, and it's going to require work, but we'll get there. So, Cristina, thank you so much. We could be going on for another few hours here, but we need to keep going with our lives. So thank you so much for participating.
Thank you so much. Thank you for having me, Monica. It's been a pleasure.
So, well, thank you all for hold on here, for participating. As always, there will be the video available in a few days, and then we're going to have the transcript as well. And also, I would like to call your attention to the fact that next week we will talk about how will AI change how humans operate telecoms is with Azita Ravani and Paul Patras. You can register for it, and actually we will have an inclusively one, which is not listed here, but it's on the website, which I'm doing with Chris Lewis, my partner at Inclusively, and that's on how on gender relationships. So we're going to have a discussion where both men and women participate. So anyway, thank you all for participating, and thank you, Cristina, for being with us today.